when we have been looking at equations, I always say one thing, right? When I've been looking at equations, we're always trying to find what that letter, that variable is. I don't know it, but I want to find out what it is. That's the whole goal of these equations. And we've seen them applied in kind of, we call them abstract situations. So if I have something like this, x plus 3 equals to 5, what is x equal to in this case? 2, right? X is equal to 2. And that seems like a kind of abstract situation because it's like, you know, oh, there's just an x here. I can just work that in my head. I don't need to do any working out, right? But why would I want to find x? What's the point of that, right? And what I want to do is, okay, we can apply this to real situations too. And I like to draw visual representations of things. But I want to do that now for a slightly different type of equation. What's different with this equation compared to that one over there? Jackson, yeah.
Okay, so the top one doesn't have a power.
Ah, okay, so look at this one. This one is just a single power of x. Now, I could put a number or coefficient in front, right? But this one, x squared, what does x squared actually mean? What does x squared?
Times x.
That's right, x squared means x times x. Does someone think they know what the value of x is in this situation? Because we've been looking at solving equations, and I'm trying to find out the answer to them. I know this one was 2, but let's look at this one. This one's slightly different now. What is the answer going to be, Trinity? 5, exactly right. And we can represent this a whole variety of different ways, because I said I like visual ways, right? And it's really clear when I think about it, how do you find the area of a square? We multiply those side lengths, you get x times x, and if I want that to be 25, yeah, if that's 5, if I just replace that with 5, does that work? It does work, right? Cool.
I mean, if they're centimeters squared, then yes.
Yeah, exactly. Oh, good point too. They have to be centimeters. They have to be in the same units. Good observation. Now, here's what we call year 8. This is what we call a quadratic equation. Okay. Any type of equation where we have a power of 2 here, right? That's a quadratic equation. Can you write that down for me? Anytime we have a power of 2, or you can say it's squared, right? That's what we call a quadratic equation. Why would we call it that? Let me give you another example to show you why we call it a quadratic equation. Have a look at this one. I want you to think, can you draw a picture which represents this? Don't just think about the answer. Can you draw a visual representation? Can you draw a visual? Don't just give me the answer, because some of you might know the answer just by looking at it. That's great. But can I draw a picture which represents this? What kind of shape would it be? What do you think, Liz? Yeah. What kind of shape? What shape did I draw over here? A square. I'm going to draw the same thing. I'm going to draw a square. All right, I'm going to draw my square. The area inside, what do you think is going to be on the inside? 36. Okay, the area is 36. Now here's the tricky part. What's going to go on the sides? I don't think we can do that one. Okay, Max has had a hand for a while. What is it going to be?
So it's going to be x plus 2. It's squared.
Yeah.
Yeah.
And x plus 2 there. Okay, right. And when I talked about looking at these types of equations, I said that we could kind of divide these up, right? This is the reason why it's called a quadratic equation, because quad, that means 4, and you can see you've got 4 little boxes here. Okay, I'm not going to solve it in this way. I'm just going to highlight why they call it a quadratic equation. When you see that word, you think power of 2, but this is why I'd go back to the visual representation, because this is where they get the name from. Does anyone actually know the answer for this one, though? Jackson?
6.
Jackson. 6, so x equals to 6?
No, x equals 4.
I think a lot of you can realize, hang on, 6 squared is equal to 36, so x equals to 4 here, okay? Is that what a lot of you guys were thinking? Yeah. Okay, I'll come back to you, Jackson, yeah? Here's my problem, year 8, though. Here's my problem. My problem is, a visual representation is one great way of looking at them. The issue with that is, we're kind of restricting our numbers. Because if you think about lengths, lengths are restricted to what kind of numbers? Full, yeah, well, I can have one. I could have 1.5 meters. So I can actually have decimal answers, but there's something that doesn't make sense when I think about the types of numbers I can have and the measurements that I usually use, right? So look at your numbers here. What kind of numbers do I have here?
Whole numbers?
I do have whole numbers. I also have,
Numbers up to 19.
yeah, numbers up to 19. What's on the other side? Negative numbers. Can I have negative lengths? Yeah, what would that look like? I don't even know. If I measured something, oh, it's -5 centimeters, like what does that doesn't really make sense, right? Yeah. But we know that when we solve equations, these answers don't just have to be positive numbers, they can be negative numbers as well. So go back to this definition, right? Hang on, if I multiply two numbers by themselves and they give me 25, 5 is an answer for that. That's correct. What would be the negative of that? What's the equivalent of that? Would this also be a solution? What's -5 times -5? 25. How come? Because a negative times a negative is a... okay. So let's go back to this one. I said in... forget this one for now. Let's look at this one over here. X squared equals to 36, right? I know that 6 would be an answer here. But what else would be an answer? Yeah, Isaac. -6. Let's double check. How can I check? I can just try it out. 6 times 6 is 36. What's -6 times -6? That's... oh, it's also 36. So we actually have two answers here. We can say x equals to 6 or x equals to -6. Right? Yeah, that's right. Oh, sorry, that was a different question over there. Can you guys get that down for me? Can you guys get that down for me? So can you see that when we solve these equations, right, we're used to our answers only having one letter that it can be. But right, now with these quadratic equations, remember what's a quadratic equation? Anytime we have a power of 2, I know I don't only have one solution, I can have two answers. That's exactly right. So what are those two answers? Make a note for me. When we look at our quadratic equations, can you write this down? We want to consider positive and negative solutions. Can you write that down for me? Consider positive and negative solutions. So anytime we see a quadratic equation, that's with a power of 2, we want to consider positive and negative solutions, okay? So when I see x squared equals to 100, that's the next one, I want to think, I think I can see one answer. What would one potential answer be? One potential answer might be 50. So if I, remember, what does x squared mean? So x squared means x times x. So I want something times the same thing that gives me 100. So 50 times 2 would be 100. But what else am I looking for? 10? Is that what you got, Nick? Okay, 10. Okay, right. So x equals to 10 is an answer. Is there another answer I can get? Oh, I think I heard it. Oh, -10, right. How can I know that that's right? Essentially, right? Essentially what's happening is I'm taking whatever is the square root of this. That's one of my answers because I know what the square root of 36 is. That's 6. But what's the other answer? I can have... yeah, so I just take whatever I found here and I take the negative of that. Okay?
Oh, so you can put the negative in front of it.
That's exactly right.
Okay.
And why is that? Remember, go back to this, right? A negative times a negative is a positive. That's why I can get this answer. Let's do another one. X squared equals to 64. What am I going to do for that one? Marissa, yeah. X equals to 8. Is that it? I think that's it. Oh, right. Remember quadratic equations, right? I'm always thinking, hang on, if this is a power of 2, then I might have two answers, right? I don't always. I might have two answers. So what's my other one? Well, if I have a negative in front of that, right, what's -8 times -8? That's... 16. Yeah, double checking your calculator. You can always check. You can always check. Question this.
If one of these questions is in a test, do we put both answers down?
What do you think? What do you guys think? Let's ask a question. If we get this kind of question in a test, do we just put one answer down or both answers?
I reckon you put down both. You know,
both.
Just so that we know it. Just because it could just give us extra marks.
You could get, yeah, maybe you get 2 marks, one for each answer. Here's the interesting thing, right? Because if you've kind of only written this, that's not wrong. That is a solution. But have you solved the equation? Because the equation says solve this. And that's not just saying find one value that's working, it's saying find all the values that work. So in that case, Liz, I'd love you to write them both down so that we know, as Jesse said, that you actually know that there are two potential answers to this. Let me give you a strange one here. Some of you might know what numbers here multiply to this one, but let me show you a way you can always work it out no matter what the value is, okay? What we want to do is, what have we been doing? How did I get from 64 to 8? How did I get from 100 to 10? What did I actually do there? I did divide it by the number, but hang on. Here's the problem, right? If I did divide this by 10, that works. If I did divide this by 8, that works. But that assumes something. What's that assuming? It's assuming I already know what the square root is going to be. It seems I already know that this is 8 squared and this is 10 squared, right? Let's say I don't know what 625 is as a square number. What's the operation that I want to do? What have I been doing? If I square something, right, I'm always telling you about opposite operations. If I square something, well, if I divide this by 2, that doesn't give me the 8. Oh, yeah. Do you guys know what that button is? Right? If you look on your calculator, can everyone find this one for me? The square root button. Can everyone do that for me?
I've figured it out.
Yeah. Everyone got the square root button for me? Can you get that in your calculator? Oh, okay, make sure you get one out.
25. I think it's 25.
It is 25, Jesse.
Is it actually? Yes.
I did it in my head.
It will take a while.
What did you get? Oh, Maddie, can you put it in for me?
I'm going to answer it wrong.
So there should be a button that looks like this. Punch it in for me. What'd you get? 25. Okay, so year 8. There's a few ways we can lay this out. Okay, I've done it here. I said like we can use or because there's 2 answers there. Here's another way you can lay it out. All right, we can say, all right, what's actually happening? Remember, I want to take the opposite operations. And what's the opposite of squaring something? Well, it's this symbol here. It's taking the square root, right? So let's take the square root of both sides. We'll take the square root of both sides. What's the square root of x squared? What does that take me to? Yes, oh, you got it. I just go back to x. If I take the square root of this, I just go back to x. But what I'm doing here is I'm taking the square root of this side here. Right? I'm taking the square root of 625. But what do I have to remember? Anytime I have a quadratic equation, what do I have to remember? I can have 2 possible solutions. How do I represent that here? Right? I did that over here by writing 2 lines. But if I was a bit lazy, we have a notation to do that. I can write it like this. A plus and a minus on top of each other. That means that there's 2 possible answers. I can have plus the positive square root 625 and the negative of square root 625, which I know as Maddie punched it in, that was plus or minus 25. Okay? So rather than writing 2 whole separate lines, what we can do is I can say, hang on, rather than write 2 lines like this with the or, I can write it as plus or minus. Does that make sense? This is saying essentially the same thing. If you prefer to write it the other way,
So you could put that in the test.
yep, that's fine.
I just do all. I think that's equal.
Yeah, if this makes more sense to you, you can do that. But often, no, it's the same thing. It's just a different way of writing it. Often we write it like this to represent that there's 2 answers there.